Good day. Today I will present how insertion sort works. So, introduction. The idea of the insertion is similar to the idea of sorting the playing cards. What is insertion sort? Insertion sort is a simple sorting algorithm that builds the final sorted array one time at a time. It is much less efficient on large lists than more advanced algorithms such as quicksort, heap sort, or merge sort. How does insertion sort work? Insertion sort is the sorting mechanism where the sorted array is built having one time at a time. The array elements are compared with each other sequentially and then arranged simultaneously in some particular order. The analogy can be understood from the style we arrange of a deck cards. Example, let's take this array. As we can see here, insertion sort, we pick up a key and compares it to elements ahead of it and puts the key in the right place. 5 has nothing before it. 1 is compared to 5, and then it is inserted before 5. So 6 is greater than 5 and 1. 2 is smaller than 6 and 5, but greater than 1. So it is inserted after 1. And this goes on. So another example, insertion sort. So we have 9275143 6. So here 9 is considered, we start by dividing the array in a sorted section and an unsorted section. We put the first element as the only element in the sorted section, and the rest of the array is the unsorted section. So moving forward, the first element in the unsorted section is the next element to be put into the correct position. So here, then the sorted one and then the item to position. So here we copy the element to be placed into another variable so it doesn't get overwritten. So we take this off, the 2 here, and then we compare. So here, in the previous position is more than the item being placed. Copy the value into the next position. So we compare here, 9 is greater than 2. So 9 is greater than, so we switch 9 here. And then if we check here, if there are no items in the sorted section to compare with, the item be placed must go at the front. So the, the 2 is being placed. So the 2 and 9 is considered as sorted and the rest are still unsorted. So here, we pick up again number 7 compared to 9. 9 is greater than 7. So yes, so we move 9 to the next index and then compare again the 2 and 7. So since 2 is less than 7, so we put the 7 next to array 2. So here 279 is already sorted and the rest are unsorted. So again, we pick number 5, compare it again to 9. So 9 is greater than 5. So 9 should be switch, and then 7 7 is greater than 5. So move the 7 and then Yeah, 2 is greater than 5 and no. So we have to put the 5 and then 2579 will be the sorted one and then the rest unsorted. So again, here, number 1, we take that off, compare to 9, 9 greater than 1. Yes, so we move here the 9, then compare again, 7 greater than 1. Yes, so move the 7. Compare again, 5 greater than 1. Yes, so move the 5. So 2 is greater than 1 and yes, so we move the 2 and then yeah, can we see any other value? So there's none, so we automatically put number 1. So 12579 is already sorted and 436 is still unsorted. So we move on. 4, we pick 4. So compare it to 9. So 9 is greater than, so we move 9. 7 is greater if 7 is greater than 4. Yes, so we move 7. We switch 7 closer to 9. Then 5 greater than 4. Yes, so we move number 5 to the vacant slot. So is 2 greater than 4? Answer is no. So that's the time that we put 4 next to number 2. Then, okay, it's already sorted out. So the remaining item, so number 3, we pick it again, compare it to 9. 9 is greater than, so we move 9 to the vacant to the vacant slot. So compare 7 3. 7 is the greatest, so we move. Compare 5 to 3. 5 is greater than, we move. Compare 4 to 3. 4 is greater than, and then we move. We move the number 4 to the vacant slot, and then compare 2 to greater than. If 2 greater than 3, then the answer is no. Then we put the 3 to the vacant box. So the remaining so 1 2 3 4 5 6 1 2 3 4 5 7 9 is already sorted. So now the last position, 6, we pick it and compare it to 9. 9 is greater than, so we move 9 to the vacant slot. Then 7 is greater than 6. 7, yes, so we move 7 to 9 to vacant slot, and then we compare again 5. If 5 is greater than 6, the answer is no. Then that's the time that we put number 6 to the vacant slot. So here we go. It's already sorted out. So this is how insertion sorting work. You have to select from the unsorted array. We have to compare it to the um, sorted array. Then shift um, the sorted one is if the sorted one is greater than, then we have to shift, then insert. So that is the last part of our presentation. So next would be I will be introducing to you the actual on how insertion works. Here it is. Okay, so these are the given variables. So for our insertion sorting, this will be our index 0, 1 to 5. So we have 6 indices, and our array 5, 3, 5, 3, 7, 6, 4, 2. Now we are gonna start on how we are going to sort it out. So first, um, we have the sorted portion, or we have the given sorted part, which is index 0. So We are going to sort the unsorted part. So the unsorted part of our array. So first we pick 1. So we started from index 1. So this is number the variable 3. So we have to ask, is 5 greater than 3? And the answer is yes. So when the variable is greater than the unsorted variable, then you have to switch it. So you have to switch, you pick this 5 and put it here. And then is it automatic that you have to put number 3 to index 0 to the sorted part? No, not really. You have to consider, you have to find if there is a variable here, or there's a value here. But since there's none, then you have to put it. So there. So next, okay, this is already for index 1 and 2. This is already sorted out. So next, we pick 1 from the unsorted part. So we pick 7. So 7 is 5 is greater than 7? Then the answer is no. So since the answer is no, then we have to put back 7, and then we consider that already sorted. So here, next we pick another one from unsorted part. So the next to it is 6 from index 3. So we pick that up, and then the question is variable 7 greater than 6? And the answer is yes. So again, when it's yes, then we need to switch it. You need to pick 7 and put it there. And now, is it automatic that we put 6 here? No, we have to check first. We have to check its next variable. So you have to consider that 5 is 5 greater than 6. Then no. So since no, then that's the time that you have to put it back. I not put it back, but you have to put it there. So it's already sorted out. So okay, we have remaining 2 indices. So here we pick 1 again from the index 4, and this is the value 4. Question: is 7 greater than 6? So if yes, again we have to switch it to index 4, and then is it automatic to put it here? No, we have to consider the variable here. So is 6 greater than 4? Yes. So since it's yes, you need to put it there. And the question is it automatic to put a value 4 to index 2? And no, you still have to consider the next variable from the index 1. So 5 is 5 greater than 4? So the answer is yes. So that's the time that you need to adjust that one to index 2, and then okay, is it automatic to put it here? You have to check first. So you have to check if 3 is greater than 4. Then no, then that's the time that you have to put it here. So it's already sorted out. So for the index until index 4, so for the last index, which the remaining value is 2, so you have to ask, is 7 greater than 2? And yes, so that's the time that you have to switch it. So pick this up and then put it there. So is it automatic to put it here? No, you still have to consider the remaining variables. So is 6 greater than 2? And yes, so when yes, then you have to adjust. Then the same thing. It's not automatic to put it here, but you have to compare it first. 5 is 5 greater than 2? then yes. Then since it's yes, you have to put it here. Again, the same the same thing. You have to question first the next variable before putting it here. So we have to consider first the following variables. So is 4 greater than 2? And yes. So since it's yes, you have to put it there. And again, it's not automatic to put it here. The 2 here, it's not automatic. So we have to consider first the next variable from the index zeros is 3 greater than 2 and yes. So we have to put it here. And do we have any value remaining here? Though there's none. So that's the time that you have to put 3. So all of those variables are already sorted out. So yeah, that's our insertion sorting. Thank you.